Hi students, welcome to today's class. In the previous class, I have explained about what is a conic section, what is eccentricity, and various definitions of conic sections, especially what is a directrix, latus rectum, focus, focal chord, all those type of fundamental definitions we have discussed. So now in this video, I am going to explain about a conic section whose eccentricity is 1. A conic section whose eccentricity is 1. That conic section, the name of that conic section is called parabola. Okay now. So let us see what is the definition of a parabola and what is the equation of the parabola, then what is the shape of the parabola, how to trace the parabola, and what is the interior and exterior of the parabola, how to define interior and exterior of the parabola. All those things we are going to see in this short videos. Okay. So don't skip this video. So it is a very important video. It gives a complete detailed explanation about the conic section, namely parabola. So first of all, before starting the class, so I will once again explain what is eccentricity. Okay. So eccentricity means what? Take a plane. In the plane, take a fixed point. Let the fixed point be P. That fixed point P or S, we call it as a focus. We are calling it as a focus. Let us take a fixed line. So this is a L is equal to 0. This is called directrix. This fixed line is called directrix. Let us consider a variable point P x comma y. It is a variable point, means it is moving in that side, this side, any direction it can move. It is a variable point, but it is maintaining certain rule. The rule is the distance between S to P and the distance between PM, this distance, that is SP by PM. SP is the distance between the variable point to the fixed point, that is a locus, and PM is the perpendicular distance from point to the directrix. This is equal to SP by PM. This we are calling it as a E, eccentricity we are calling it as. This eccentricity may be greater than 0, it is always greater than 0. It is a positive quantity. It cannot be negative. It may be greater than 1, maybe less than 1, maybe it tends to infinity. So in the previous class I have explained. If this E value happens to be is equal to 1, that means SP by PM is equal to 1, that is equal to SP by PM. That means if these two distances are equal, that means what? If it is a 5 centimeters, this is also 5 centimeters, 5 by 5, 1. If point comes here, SP by PM, if it is a 3 centimeters, this is also 3 centimeters. If the point comes here, SP by PM, this is a PM. If it is a 2 centimeters, this is also 2 centimeters, SP by PM is equal to 1. So if it is a point here, then SP by PM, if it is a 3 centimeters, this is also 3 centimeters. So if we join all these points, you will get a curve, The name of that curve is given as parabola. Okay, na? The name of the curve is given as parabola. So what is the eccentricity of the parabola? 1. Okay. Once we draw the curve, we got a curve. So now we are interested to find the equation of that curve. Okay, na? Now we are going to see the equation of the parabola. So I will explain this equation in a very simple method, okay, so that you can remember it forever. Okay. So let us see the equation of the parabola. So welcome to the concept. It is a equation of the parabola. Okay, now right. So to find the equation of the parabola, first thing, without loss of generality, generally whenever we have to find out the equations of any parabola, ellipse or hyperbola. So first we will take the general case we will take. Okay, now. So let us take this two-dimensional plane. So this is x-axis and it is y-axis. Okay. So, x-axis, y-axis is a two-dimensional plane. So, it is a origin, let us call it as a A. The first thing is we have to consider a fixed point. So, actually speaking, a fixed point may be anywhere in the maybe in the first quadrant, second quadrant, third, fourth quadrant, anywhere we can take. But without loss of generality, so to find the basic equation of the parabola, let us take for our convenient the point S lies on the x-axis, Let the coordinates of S be a comma 0. Since it lies on x-axis, the point y coordinate will be 0. Okay now, right. Let px comma y be a variable point. Let px comma y be a variable point. Now we have to take the directrix. Okay now, let us take the directrix. Let us suppose that P coincides with A. So, let us suppose that P coincides with A, that is the origin. Then this length will be A units. That means P may be anywhere, If the P coincides with A, then the SA length will be automatically A. By definition, we have SP by PM is equal to 1. SP by PM is equal to 1. That means here already A coincides with A. That means SA by AM. M will be here. So, this will be your directrix. That means SA by AM. So, let us call it as a Z. So, this length is also A. That means SP by PM is equal to 1. Let us join this. SP by PM. So, this is a PM. So, we know that SP by PM, PM is called as a eccentricity. That eccentricity is equal to 1. Then we have SP is equal to PM. Okay now, SP is equal to PM. Let us drop the perpendicular here, call it as a N. Let us call it as a N. So, here we have SA is equal to AZ is equal to A. Yes, if P coincides with here, SA by AZ is equal to 1. Clear? Right, happy. Here we got SP is equal to PM, since eccentricity is equal to 1. So, this implies SP is equal to, in place of PM, can I write down NZ? So, here PN is perpendicular to the x-axis. Okay. In place of PM, can I write down NZ? Yes, I can write down NZ. NZ. So, squaring on both sides, that is equal to SP square is equal to NZ square. What is the length of NZ? See here, P coordinates are x comma y. That means A to N is x. AN is x, that is why here x coordinate is there. Here AN is x and his AN is equal to x. Okay now. So, what is NZ? He is asking up to NZ. This means this is also A. Okay. Now, SP square means what? Without square root. That means x2 minus x1 whole square, y2 minus y1 whole square. So, this is equal to x minus a whole square plus y minus 0 whole square. What is length of NZ? NZ means up to N to A is x, from A to Z is A, that is A plus x plus A whole square. Understand this? Now, simplify it, x square minus 2ax plus a square plus y square is equal to x square plus 2ax plus a square. So, this is equal to x square cancel, a square cancel, take minus 2a to right hand side, you will get y square is equal to 4ax. Y square is equal to 4ax. So, this is the equation of the curve. This is the equation of the curve which satisfies the condition SP by PM is equal to 1. The name of that curve is given as parabola. The name of the curve, parabola. That means the curve whose equation is y square is equal to 4ax is called as a parabola. So here, see here, in any equation x and y must be there. If it is a two-dimensional geometry, any curve, it should have a x and y. But what about a? So this a, you should know what is a. So this is the distance between the focus to the vertex. So already we know the definition of a vertex. The definition of vertex we have already, yesterday's class I have explained what is the definition of a vertex and vertices. What is the definition of a vertex? So it is a point which it is a point of intersection of the curve and axis of the curve. Axis of the curve and axis. The point of intersection is A. That A is called vertex. So the distance between the vertex to the fixed point, that is focus, is the distance is equal to A. This is the A. That you should be remembered clearly in this way, because y, x are variables, 4 is a constant. What is A? That you have to be very specifically, you have to know that A is the distance between the focus to the vertex. For a parabola, the distance between the vertex to the directrix is also same. Why? Because SA by AZ is equal to 1. Understand? So this is called equation of the parabola. Understand this? So very nice, very simple definition. This is a I hope that you understand this derivation. So let us see how to trace the curve. How to trace the curve. So here x value, y value, already he has taken variables. That means x can take any value, y can take any value. If x is equal to 0, what happens? If it is x is less than 0, what happens? If y is less than 0, y greater than 0, what happens? What is the nature of the curve? What are the characteristics of that curve parabola? Let us see that. Welcome back. So here we are, the concept is tracing the curve y square is equal to 4x. So what is the concept means? Generally, if anybody asks you, so what is the parabola means, immediately they will draw the parabola like this. Y square is equal to 4x, they will draw one curve like this. But mathematically, how to trace the curve y square is equal to 4x? Here a is a constant, so that we cannot do anything. So here x and y are variables. Okay now. So that x can take any value, y can take any value. Let us see that. Welcome to this concept. So here tracing of the curve y square is equal to 4ax. Okay now. Tracing means what? Then what is the shape? They are simply saying that y square is parabola means like just like we are drawing like that now. So here already we explained x and y are both are variables. That means x can take any values, y can take any values. Of course, there are some restrictions I will tell. A is a constant. So that is the distance between the focus to the vertex is A. Now let us see that our curve is y square is equal to 4ax. First let us take x is less than 0. X less than 0 means, see here, the right hand side part of the equation will become negative. Why? Because A is a positive value. A is positive. Why? Because A is the distance between the focus and the vertex. Distance between the focus and the vertex, that is a distance. Distance is always a positive quantity. 4a is a positive. Therefore, altogether right hand side is negative. Now, y square is negative. That means, is there any number whose square is negative? No. That means, from this we can say that the curve, that means x less than 0 means which side? From which side? From A to left hand side. A to left hand side, negative x axis. That means your curve does not exist to the left of A. Your curve does not exist to the left of A. This side your curve does, it won't come. Y square is equal to 4ax, I am telling. Y square is equal to 4ax curve. The curve does not come to the left of A. So it whatever may be that, it will lies to the right of A. So that is the first thing. Now x greater than 0. if x is positive, then y square is equal to 4ax, then y square is equal to some positive quantity you will get. Therefore, y is equal to plus or minus y square some number. For example, if y square is equal to 4 you got, x value is 1, a value is y square is equal to 4. Therefore, y is equal to how much? Plus or minus 2. Plus or minus 2. That means for every x1 value, you are getting 2 y values. For every one x value, you are getting 2 y values. That means for if it is a x value is here, you are getting a 2 y values. If you observe here, this quantity is equal in magnitude, but opposite will be in sign. That means whatever may be the curve lies above x-axis. That means if there is a pointer above here, for example, if it is a n, definitely there will be another point here, same distance. This is a distance, this is a n dash. That means if there is a point here, another point here. If there is a point here, there is a point here. If there is a point here, another point here. So your points will be like this. So here for if you take a x1 value, you are getting 2 y values whose magnitudes are same but opposite in direction. That means y is equal to plus or minus 2 means what? So if you get a pointer here, then there another point will lies below the x-axis of the same length, of the same distance from the x-axis. Understand? So that is a second tracing, that we have an idea. Okay, now right, next one. Automatically if x is equal to 0, y is also 0. If y is equal to 0, x is also 0. From this, what is the conclusion we get? The curve passes through the origin. The curve passes through the origin. Understand? That is the thing. Clearly. Second one is, if x tends to infinity, y square is equal to 4ax, x value is in the right side of the equation. If x value goes on increasing, already a is a positive quantity, so y square, that means y square is also goes on increasing, and x is also goes on increasing. That means this curve extends indefinitely. Indefinitely he will say. That means it curve extends indefinitely. That means whatever may be the shape of the curve, above the x-axis and below the x-axis, both are same. Both are same. And it means we can say that as x tends to infinity, y also tends to infinity. That means if you goes on increasing, y will also goes on increasing. Thereby for every point above the line, there exists another point below the above the x-axis, there exists another point below the x-axis. Therefore, it extends in the both branches. Both branches extends indefinitely. That's why we can say that there won't be any intersection point of these two branches. That means they won't meet the anywhere. You may ask one doubt, sir, if goes on increasing, somewhere they will meet. No. Why? Because here you see here x greater than 0. For every x value, you are getting a 2 y values. One is positive and one is negative. Therefore, there is no chance of meeting these two branches. We can call it as a branches. Understand this? So this is called the tracing of the curve. So our curve is in the shape of just like a U shape. Understand? So this is how we can trace the curve. So this is x less than 0, x greater than 0, passes through origin, as x tends to infinity, y also tends to infinity, and it is a concave shape. And also we can say that it is a symmetric about x-axis. Symmetric about x-axis. Understand? Symmetric about x-axis means what? Whatever may be the shape of the line, whatever the shape above the x-axis, below the x-axis also same shape we will get. That means we can fold it with respect to x-axis. It is a symmetric about x-axis, and it does not lie to the left of the vertex. Okay, I hope that you understand this concept. But don't go away, don't skip this video. So I am going to explain a very important. Just now I explained this. It is a open curve. It is an open curve. But what is the interior and what is exterior? What is the interior of the curve? What is the exterior of the curve? If given a point, if any point is given, then how to say that which is whether it lies in outside the curve and inside the curve. So that I am going to explain. So let us continue our chapter. So here I am going to explain what is interior and exterior of a parabola. As I already told you, parabola is a open curve. Open curve. Circle is a closed curve and this is a ellipse. Afterwards I will explain what is a ellipse. Okay. And one more curve is also there. This is a hyperbola. This is called hyperbola. I will explain afterwards these two concepts. So here circle, ellipse are simple closed curve, whereas a parabola and a hyperbola are open curves. For this closed curve, even a small child also can tell what is interior, what is exterior. Anybody can say. So it is a interior means this part is called interior. Here also this part is a interior. Outside part is exterior. Anybody can say. This is a exterior. But for an open curve, what is interior, what is exterior? How can you say that? Is it interior? Is it exterior? Some may say that they may consider it is an interior, outside interior, this may be exterior. But this is exterior, that may be interior. Otherwise it is interior, what is exterior? What is interior? How to define? Is there any definition for that? Or simply we can say that as we like? No. For this, there is a definition for this. The mathematicians, they define what is interior and what is exterior of this type of open curves. Let us see the definition of interior and exterior of the parabola. So don't skip this video. Welcome back. So the interior and exterior of the parabola, the definition is here. So see, observe carefully. Definition is very clear. The region, it is a region. I am explaining the first interior I am explaining. The region lies between the parabola, or the distance the region lies between the parabola and the axis, and this is, we call it as axis. This is parabola. So the definition is the region lies between the parabola and the axis. The parabola and the axis is called as interior of the parabola. Once again I am telling, the region lies between the curve, parabola and the axis. This means, is it not this region? So this is the region. Same as this also, this also, this also. So this also. This is named as interior of the parabola. Interior of the parabola. Automatically, if that is interior, this part is exterior. See the definition once I am telling. So the region lies, which lies between the parabola and the axis of that parabola. The curve and the axis of that curve. If it is a general definition I am telling, the region which lies between the curve and the axis of the curve is called interior of that curve. Understand? The other one is exterior of the curve. Otherwise, we can say another definition also is there in some textbook. In some textbook, another definition is also there. The definition is, it is the region, it is a closed region, it is the region where the focus is there, where the focus lies. The region, the bounded, this is a region may be bounded or open. It is a region where the focus is there. That region is called interior region. That means here, if you observe here, in this region only focus is there. That's why this is interior region. The definition also we can say. Understand? So on the parabola means everybody can say. What the parabola, on the parabola means, this is the set of points which lies on the curve is called on the parabola. So we have seen the interior, exterior of the parabola, open curve. If it is a closed curve, no problem. If it is open curve only, the definition requires. That is a parabola and the axis. That is a parabola and the axis. Okay. So this is called interior of the curve. Okay. I hope that you understand this concept. Our next, don't go away. Our next concept is, given a point, then how to say that whether it lies interior of the curve or exterior of the curve. So in your general classes, then everybody will say that some notations will be there. S11 is less than 0, it lies inside the parabola. If S11 is greater than 0, it lies outside the parabola. S11 means y1 square minus 4ax1. How it comes? How that formula it comes? I am going to show you the derivation also I am going to see. So please learn this concept, this topic conceptually. Okay, how, why if it is a S11 is less than 0, the point lies inside the curve. So don't go away. So please watch this concept also. Okay, let us start our concept. Welcome back. This is a very easy concept that where I am going to explain. That is a position of a point with respect to a parabola. That means given a point, any point some x1 comma y1, how to decide without drawing the graph, how to decide whether it lies inside the interior of the parabola or exterior of the parabola on the parabola. On the parabola means it is a very clear concept. That is we will substitute that point in the equation. If the equation is satisfied but by that point, then we can say that the point lies on the curve. Then how to decide whether the point lies inside the parabola or outside the parabola, okay, interior of the parabola or exterior of the parabola. Let us take a graph of the parabola y square is equal to 4ax. So this is equal to y square is equal to 4x. Now let us see the geometrical interpretation of this y square is equal to 4x. What is y? See here, this length is px comma y, be any variable point we are saying. So here y means this length is y, that is equal to pn. Pn square is equal to 4 into a means what? What is a? This is a distance between a and s. This is a distance between a s. This is equal to a into s, 4as. What is x? What is x? This length is nothing but, this length is nothing but x, this length is nothing but y. Okay, now a and length. That's why we this point of px comma y keeps. So x means an. So this is the geometrical interpretation of the pn square is equal to 4 into as into an. That is pn square is equal to 4 times as into an. 4 times as into an. So that is the geometrical interpretation of the the equation y square is equal to 4ax. Now let us take any point interior of the parabola. First of all, let us take this point q x1 comma y1. Q x1 comma y1. Let us take the point q x1 comma y1. Let us see here, this is equal to pn square is equal to, now pn square is equal to 4 into as. As means a. An means how much here? We can take x1 also. Why? Because this q is also lies on pn. This q is also, I will rub it. I can rub it. This is a. So this q is also lies on pn. Therefore, this an length we can call it as x1. So therefore, pn square is equal to 4a x1 we can take. Okay. So let us call it as a 1. Now you see here, very easy concept. When q lies inside the parabola, is it not qn is less than pn? Clearly from the graph, qn is less than pn, no? Qn is less than Pn. Why? Because Q lies inside the parabola. Okay, right. Since Qn and Pn both are positive quantities, we have Qn square is less than Pn square. Yes. Qn square means what? So this is a Qn square. Qn. Where is Qn? Qn is nothing but y1. Qn is nothing but y1. Y1 square is nothing but, what is Pn square? What is Pn square? This is a 4ax1. Understand? Take this side, y1 square minus 4ax1 less than 0. This is we denoted as S11 is less than 0. So this is the reason S11 is less than 0. Okay now? Right. So this is the derivation. That means if you substitute that point in the equation, that means the left hand side of the equation, y square minus 4x is equal to 0. If you substitute that point x1, y1 in the left hand side of the equation, that is a y1 square minus 4x. If you get a negative answer, that means if you negative value, we can say that that point lies inside the parabola. If it is outside, let us see that. Let us say that point is here, qx1 comma y1. So your point is above the point px comma y. From the diagrams, we can say clearly we can say Qn is greater than Pn. So Qn square is greater than Pn square. What is Qn? Qn is x1 comma y1, no? y1, y coordinate. y1 square is greater than. What is Pn square? 4ax1. 4ax1. So take this side, y1 square minus 4ax1 is greater than 0. We denote it as y1 square minus 4ax1. We denote it as x11 is equal to 0. Okay now? So like that, that means we will substitute the point x1 comma y1 in the left hand side of the equation y square minus 4ax is equal to 0. Left hand side in this y square is equal to 4ax. If it is a positive, the point lies exterior of the parabola. If the point lies inside the parabola, we will get less than 0. Okay. If it is equal to 0, if it satisfies, then the point lies on the parabola. Okay. I hope that you understand this concept. I have explained the derivation also. So I hope that you understand this. Dear students, I hope that you are enjoyed today's class with some more concepts and some more definitions. Tomorrow's class, I will stand before you. Until then, all the best.